Okay, so the first thing we're going to look at for this section is the change of base formula. You're going to have to memorize this, which I don't think is very hard to do. If you have log base c of a, your change of base formula tells you take the log of a divided by the log of c. That's it. Okay? And if you're doing it to a natural log, then you just, if I say use the change of base formula to a natural log, then you just do the natural log of a over the natural log of c. I think it's easy. This number, when you have it, is written larger. It goes on the top. That's how I always memorized it, but I don't think that's hard to memorize. Okay? So if it says use the change of base formula to evaluate the logarithm, round answers to 4 decimal places. So log base 3 of 8, I'm going to have log of 8 over log of 3. So in your calculator, you're going to set up your fraction and then do second log. You're doing log of 8 over log of 3. You should get the same decimal. So if I'm rounding to 4 decimal places, what's my answer? Very good. Okay, very simple. So if I have log base 8 of 14 to a natural log, that's whenever I'm going to do the natural log of 14 over the natural log of 8. So I set it up in my calculator. When you need natural log, you just go to the right, and you will see your natural log in your e-base. Okay, if I'm rounding that to 4 decimal places, what do I get? 1.2691. Okay. So, this next section. So, everything we do with logs is log base solution equals exponent. Okay? Now, it says to memorize. I already have everything there, but we're going to do the work as to why are these equal to what they're equal to. Okay? So, if I didn't know, if all I gave you was this, we're at the point now, if I give you this, you should tell me 1. You shouldn't have to do any work. Okay? So the algebra behind it is, if I didn't know it was equal to 1, I would put it equal to x, right? And then log base solution equals exponent tells me 6 to the x power equals 6. Well, that's a 1. X is equal to 1. So that is why that's equal to 1. Okay, it's not just for 6, it's for anything. So if I have log base b of b, that's always going to be 1. Okay, that's my general rule. So I don't want you memorizing the 6, I want you memorizing the rule. Okay? So if I have log base 3 of 3 squared, okay? If I didn't know that it was equal to 2, I have log base 3 of 3 squared, and I set it equal to x. So that means 3 to the x power is equal to 3 squared. There's my x equals 2. Okay? So my rule is, if I take the log of, with any base, of base to the n power, then that's just equal to n. So log base b of b to the nth is equal to n. Okay? Now we have already also talked about if you have b raised to the log base b of n, that's also equal to n. So remember, we covered that last class. A whole bunch of rules you're going to have to be able to recognize. Okay? Now, natural log of e is equal to 1. I mentioned that last class also. That's because the natural log has an understood base of e. So e to the x is equal to e. X is equal to 1. So you just need to know the natural log of e is 1. And then the natural log of 1 will always be 0, because if you think about, you've got natural log of 1 equals x. E to the x is equal to 1. The only way you're going to get a 1 with any random base is going to be if it's raised to the 0 power. Okay? Anything to the 0 power is 1. So even if I did log 1, that's still 0. Okay? Alright. So now we're doing properties of logarithms because we're going to expand and condense. Okay? I don't think these are really hard. You're just going to be writing, when you're expanding, you're going to be writing a lot. Okay? Your product property tells me that if I'm multiplying two things, so log base b of m times n, then I can separate my m and n and add log base b of m plus log base b of n. Okay? Just like if I had the cube root of 8x squared. That's the same as the cube root of 8 times the cube root of x squared, right? I can just split whatever's already being multiplied. Now, I understand I'm not adding here, but I want you to see that you're just splitting what's being multiplied, okay? And then when you multiply, you add. To me, that those two are your only two operations that get larger. To me, they go hand in hand. And you know, when you're multiplying with exponents, with bases, what do you do with your exponents? You add them. So to me, I don't feel like that's hard to memorize, okay? And then your log base b of m divided by n, you're just going to be subtracting off that denominator. Okay, so when you divide, you're going to be subtracting. Okay? Now, this might be a little new, but this is not hard either. If you have log base b of m to the p power, then all you're doing is bringing that power over to the front. Okay? When you get to calculus, y'all will have a power rule, and it's going to be basically the same thing. Okay? So we're going to be using those to expand, and then we're going to use those to condense. Okay? So if I have log base 6 of 5x cubed over y, I'm taking my numerator and separating it from my denominator. So that means log base 6 of 5x cubed. It's division, so I'm going to subtract log base 6 of y. Okay? Now I need to separate what's being multiplied. You'll follow me? So I need to separate that 5 and that x cubed. So I'm going to have log base 6 of 5 plus log base 6 of x cubed minus log base 6 of y. Okay? Now the only thing I have left to do is bring this exponent. Anytime you expand, you don't want any exponents. You're going to use your power property and bring it directly to the front of that term. So I would have log base 6 of 5 plus 3 log 6 of x minus log base 6 of y. I can't do any more expanding, so that is my answer. Okay? Y'all understand how we used our properties there? Okay. So here I have log of 3x to the 4th. I don't have a base written. It's understood to be 10. I don't have to put the 10 whenever I do my work. Okay? So if it's being multiplied, I'm going to split my 3 and my x to the 4th. So I'm going to have log of 3 plus log of x to the 4th. And then my last step would be to take this 4 and bring it out front. So log of 3 plus 4 log of x. We good with that? Okay, so now I have the natural log of the cube root of x to the fifth. Okay, remember that the cube root of x is the same as x to what power? The 1/3, right? So the square root of x is x to the 1/2. The fifth root of x is x to the 1/5. Okay, so you're going to use this knowledge to figure out how do I simplify this. So this is the same as the natural log of x to what power? 5/3. Okay, because your rule, the nth root of a to the m power is a to the m over n. Okay, so that's what we just did with the cube root of x. So you put it in your exponent form. Now the only thing I have to do is what? I can't separate because I only have one term. I only have one x. But I can take that exponent right to the front. So it's going to become 5/3 natural log of x. Now I understand 5/3 is a fraction, but that's not the natural log of 5/3 to be separated. Okay, so you're going to have to get those separate in your head, that this fraction exponent is okay to be right here. I don't have to do like 5 natural log of x minus 3 natural log of x. Okay, I don't have to split that exponent. Okay, so log of x cubed over 2y to the fifth. Okay, I am splitting x cubed and 2y to the fifth. So I'm going to have log of x cubed. When I divide, I subtract, so minus log of the entire 2y to the fifth. You're going to have to be careful when there's more than one term there. Okay? So, I have two terms in my denominator. I need to split this. Okay? So I'm going to have log x cubed minus log of 2. Now, am I going to have a minus or a plus for y to the fifth? No, it's just 2y to the fifth. So plus means it would be where? In the numerator. So what you're doing is you're subtracting the entire thing, right? So you're subtracting this. So if you are thinking plus, then what's happening is you're subtracting log of 2 plus log of y to the fifth. But what am I doing essentially with this minus? I'm going to have to distribute it. So shortcut, no matter what is in the denominator, you have a minus there. Don't do this added extra step, okay? Anything in the numerator will be plus. Anything in the denominator, you're subtracting off, okay? Because of this concept right here. I would subtract between these two, but if I have to split this, then that's multiplication, but I'm subtracting that whole 2y to the fifth. So I've got log x cubed minus log 2 minus log y to the fifth. So however many terms, even if you have 20, everything in the denominator will have a minus in front. Okay? Alright, now I just need to bring my exponents out front. So 3 log of x minus log 2 minus 5 log y. Okay? Alright, now we're going backwards. I give you the expanded version, and we're going to condense it. You condense it all the way till you have one logarithm written. Okay? So I have log of 3 plus 3 log of 4 minus log of 6. So I know that when I have a number in front of my log, that goes here. Okay? And I know that when I'm adding, I'm multiplying. So I have log of 3 times 4 to the third minus log of 6. I don't ever want you doing more than like 2 things in one step. Okay? I know that y'all are advanced, that's why y'all are in this class, and I know that you should be able to go there to your answer. But with no work, I'm not going to follow your process if you get it wrong. Okay? So I want to see you do that. You don't necessarily have to do log of 3 plus log of 4 cubed minus log of 6. I'm okay with you doing 2 things in one, just not more than that. Okay? So then this is going to be 3 times 64, which is what? $132? Huh? 92. 192. My ears aren't working. Okay, and this minus tells me I should be doing what? Dividing that with 6. Can 192 be divided by 6, or can it simplify? I heard that one. Log of 32. Are we okay? Alright. This next one, 2 natural log of 5 plus 3 natural log of x minus 6 natural log of y. All of those become exponents. Okay? So I've got natural log. I see that I have a plus. So I'm going to be multiplying 5 squared and x cubed. Then minus the natural log of y to the 6th. So that becomes natural log. I know I'm going to have a fraction because I have a minus. So my numerator becomes what? 25x cubed. 5 squared, 25 times x cubed. And then my denominator is y to the 6th. Questions on that? Okay. I want you to do the next one. Okay, so for here, I've got 2 times log base 3 of 10 minus log base 3 of 5 plus half of log base 3 of 9. Okay, this parentheses right here, what am I doing with that? I'm dividing 10 and 5. Which is what? 10 divided by 5? 2. Okay. Now I have this 2 that needs to become an exponent and this 0.5 that needs to become an exponent. So log base 3 of 2 squared plus log base 3 of 9 to the 0.5 power. Well, that is 9 to the 1/2. A lot of people don't recognize it as a decimal. Okay, so that's 9 to the 1/2. So I have log base 3 of 2 squared is 4 plus log base 3. 9 to the 1/2 is the square root of 9. Okay, now the square root of 9 is what? Plus or minus 3. Do I use both of them and create 2 answers? Because why? You can't take the log of a negative number. So you're only going to use the positive. So I'm going to have log of 3, log base 3 of 4 times 3. So log base 3 of 12. So most instincts, anytime you see a number in front of parentheses with at least 2 terms, it's drilled in y'all's head to distribute, right? Not when they're like terms. Okay? Now, could you have? Yes, you would have gotten 100 divided by 25, which gives you 4. Okay? Is it going to be wrong? No. I just wouldn't. Okay? Because I'm having the log of the same base, so I would condense that. Think about your order of operations. You do parentheses first when you have like terms. Okay? But either way, you get down to that answer. Alright? Do we have questions on that? Okay, this next section. I remember when I was a student, I could not stand this section of logs. It's really not that hard now. But as a student, I couldn't stand it. Okay? You are going to be expanding and manipulating. And it was really hard for me to wrap my head around that. It might not be hard for y'all. Okay? But I'm just saying it was hard to expand and manipulate. So if I give you a specific logarithm, okay, and then I say, okay, here is this value. Find log base 3 of 45. Well, how am I going to do that if all I'm given is log base 3 of 5? The key is using numbers that are the base and numbers that are in the solution position of the log. Okay? So that means if I'm given log base 3 of 5, I can work in 3 and 5. I can work in those numbers. Okay? So I can expand log base 3 of 45 because 45 is what? 5 times 9. Knowing that I need to break it to a 5 is not hard. Okay? Here, 9 isn't any part of this. So if I'm doing log base 3 of 5, now I'm multiplying, so that means I add log base 3 of 9. I'm good with this, but I'm not good with this. But 9 is 3 squared. I can work in 3's. Okay? So I have log base 3 of 5 plus log base 3 of 3 squared. Okay? When I was a student, my first instinct was to bring my 2 over because I just got done expanding and all of that. Okay? That's not what you want to do. Bless you. Remember the rule, log base b of b to the nth is n. Okay? So this is just 2. Knowing those rules that I said to memorize is going to be key for you walking through the section with breeze. Okay? So now I have log base 3 of 5 plus 2. Well, log base 3 of 5 is 1.465 plus 2. So my final answer is what? Okay? Do we understand what I did? It's not the worst thing. Trust me, not the worst thing. But it wasn't, I just didn't like it. So, log base 4 of 5 is 1.161, and log base 4 of 15 is 1.9534. Find log base 4 of 5 over 16. I'm going to start by separating. Okay, before I do anything, that's going to be my first step. So log base 4 of 5 minus log base 4 of 16. So what numbers can I work with? 4, 5, and 15. I can manipulate 16 to become what? 4 squared. Did I need log base 4 of 15? I can give you more than what you need. Okay? So 15 has nothing to do with 5 and 16. Okay? Now here, log base 4 of 5 is 1.161 minus, that whole thing is just 2. Which is going to give me what? Negative what? Okay. So if I gave you the inspires, you could type this in and go directly to this answer. But I'm not giving you that. Okay? Once you graduate from my class, then you can do that. Okay? Alright. Do the next one. Next one's easy. Okay, how can I split 80? 80 is 8 times 10, right? So I can do log base 12 of 8 plus log base 12 of 10. There's my 0.8368 plus 0.9226. And that's going to give me 1.7594. If you are good with breaking down numbers, this is not going to be hard. If you have a mental block on breaking down numbers, which would be me, it's not fun. Okay? If you have questions, let me know when you start doing your worksheet. Okay? Now the rest of it, we're solving log equations. So remember, you want to check to see if you're taking the log of 0 or the log of a negative once you get your answers. Okay? What you want to do, so each problem would be different, but if you start with a log, a bunch of different ones, you want to condense it down until you have a log on the left, log on the right. Okay? So if I have 2 log base 3 of 6 minus 1/4 log base 3 of 16 equals log base 3 of x, I'm going to condense and bring those exponents back to where they belong. Okay, so I have log base 3. I know I have a minus, so I'm going to have a fraction. That's going to be 6 squared and 16 to the 1/4. Okay, well, 6 squared is 36. 16 to the 1/4 is the 4th root of 16, which is plus or minus 2, but we know you're only taking the positive. So, 2. So that means log base 3 of what? 36 divided by 2 is 18 equals log base 3 of x. So x is equal to 18 because of our 1-to-1 property. I would plug it back in. The only place I need to plug it in is here. It's a positive, so I'm good. Okay? Alright, the next example, I have log of z plus log of z plus 3 equals 1. Now, I don't have logs on both sides, okay, but that's okay. I'm still going to condense it down to 1 log. So, I have log, this plus tells me I'm multiplying z and z plus 3. Well, what is z times z plus 3? Z squared plus 3z. That's all equal to 1. Well, how do I solve that if I only have 1 log? So if I was solving for x and I had 2x equals 4, what would I do? I would divide by 2 because that's the inverse operation. If I had x squared equals 36, I would take the square root because that's its inverse operation. What's the inverse of a log? Exponential form, right? Logarithmic and exponential functions are opposites. So if you have 1 log, you're going to put it in exponential form. I don't have a base, so how do I put it in exponential form? It's understood to be 10. Remember, your log base solution equals exponent. Okay, so that's going to go to 10 to the first power equals z squared plus 3z. Anytime you have a squared term, what do you need to do? Get it equal to 0 and factor. Okay, so I'm going to subtract my 10, and I have z squared plus 3z minus 10 equals 0. So that's going to factor z plus 5 and z minus 2 equals 0. So z equals negative 5 and z equals 2. It's going to be 2. I cannot have the negative 5 because if I plugged it in, I would get the log of a negative. Okay? Alright, natural log of x equals 6. Here again, I just have one log. It's a natural log, but I just have one. So I'm going to put it in exponential form. So log base, my base is e to the 6th power is equal to x. So I'm going to get, it says round decimal answers to 3 places. It says that in the instructions. Okay? So you can type that, do your second log, go over to natural log, and then there's your e to the 6th. So x is equal to 403.429. You want to try the next one? Y'all try that. Okay, you should start by moving your exponents back. So you have log base 3 of y is equal to, that should have a 3. Sorry. Oh, I'm sorry. Sorry. My bad. Okay. Just know I will never give you a problem that is unlike bases. If it looks like it, it's a typo. Sorry. So, log 3 of 16 to the 1/4 plus log 3 of 64 to the 1/3. So then log base 3 of y is equal to log base 3. What's the 4th root of 16? And then the cube root of 64. Okay. So log base 3 of y is equal to log base 3 of 8. Y is equal to 8. Okay? Okay. This last section, there's a lot to these two. Okay? It's like a little introductory and then the big parts. So if you have exponential functions, of course we try our best to get like bases. We've already done that. Okay? I'm not going to give you like bases here. I'm just going to tell you. Okay? So we're going to use our properties of logarithms and y. Well, because of the fact that they're inverse. So if I have something raised to the x power, the only inverse I have is to take the log of that. Okay? So what you're going to do is you're going to isolate whatever you need to isolate that is being raised to the exponent. Okay? Here, it's already isolated. So what I'm going to do is I'm going to take the log of both sides. So I'm going to take the log of 6 to the x power and the log of 42. And I'm going to use my properties to get x. Well, x is still my exponent, so how does that work? I use my power rule. I bring this x over to the front. So x times log of 6 is equal to the log of 42. How am I going to get x? I'm going to divide by a log of 6. So that's going to be x is equal to the log of 42 over the log of 6, which is not 7. Okay? I want to make that clear. That's not 7. You're going to type in, and this is going to teach you to pay attention to details. If you lack attention to detail, you're going to learn it now when you type stuff in your calculator, okay? So set up your fraction, and then do your log of 42 over your log of 6. And then you're going to round, let's say, 4 places. Okay, do we have questions on how we did that? Okay, so 6 raised to the 3x plus 1 equals 8. It's isolated, so I'm going to take the log of both sides. I know I need to move my exponent to the front. So I've got 3x plus 1 as a whole. Then your log of 6 equals log of 8. Okay, I have a 3x plus 1. That was my full exponent. I need this x. The only way I can break this x from this is if I distribute this log of 6. Okay, they're not like terms, so I can distribute. Okay, so that's going to be 3x log of 6 plus log of 6 equals log of 8. If you are not the nicest, like your penmanship is not the nicest or the neatest, make your best effort because you're going to have the word log all over this paper with some variables and numbers thrown in all over the paper. Make sure I can follow your work, okay? Alright, so I need this x. So I'm going to subtract log of 6. So I have 3x log of 6 equals. Will log of 8 minus log of 6 become log of 2? No. Please don't do that. Okay, they're two separate terms. So I just copy it down, log of 8 minus log of 6. Now I need this x. What do I need to do? Divide by 3 log of 6. So x is equal to log of 8 minus log of 6 over 3 log of 6. So you type that in your calculator. Anytime I have more than one thing in my denominator, I put it in parentheses just to be safe. Okay? So I'm going to have 3 times my log of 6. So if I round to 4 decimal places, that's going to be 0.0535. So now I have 8 to the 2x minus 5 equals 5 to the x plus 1. I'm going to do the log of both sides. And then I'm going to take my exponents, bring them out front. So 2x minus 5 in parentheses log 8 equals x plus 1 in parentheses log 5. What am I going to do next? I'm going to distribute. So I have 2x log 8 minus 5 log 8 equals x log 5 plus log 5. I have an x on the left and an x on the right. So what do I need to do? I need my x's on the left. So I'm going to move this over, and I'm going to move this term that has nothing to do with an x over. Okay? So I'm going to have 2x log 8 minus x log 5 equals log 5 plus 5 log 8. Y'all follow me? Okay. I still have 2 x's. But log 8 and log 5 are not like terms. What can I do? I'm going to take that x out as a GCF. If it's in both terms, you can factor out a GCF, right? So I'm going to take this x out, and that becomes 2 log 8 minus log 5 equals log 5 plus 5 log 8. Now how am I going to solve for x? I'm going to divide by the whole thing. So x is equal to log 5 plus 5 log 8 over 2 log 8 minus log 5. And I expect to see that final step. Don't just jump to the answer from the calculator. So I have all of that in my calculator. Very carefully. So that's going to give me 4.7095. Okay. I'm going to pick it up a little bit because we got 8 minutes to the bell. These last two examples, y'all just need to go look at the notes in the Google Slides and grab them from there. I don't think they're going to be hard for you to figure it out. This one, you just move the 2 and then you're back to examples from up here. Okay, so that's not hard. This is just knowing your natural log stuff. Okay. This one, though, I want you to do together. So here, I've got the fourth root of 3 raised to the 4x plus 5 equals 7 to the x. Okay, well, the fourth root is the same as 3 of the 1/4 to the 4x plus 5. Okay, so this is going to be 3. 1/4 times 4 is just 1. So x plus 5/4 equals 7 to the x. Okay? So I'm going to take the log of both sides. Bring those exponents to the front. In the same concept, I distribute. So x log 3 plus 5/4 log 3 equals x log 7. The moment you have x's on both sides, you're going to move it over. Now you can move this one over to the right. Personally, I would do that, because there's no sense in moving one and moving the other, right? So I'm going to have x log 7 minus x log 3 equals 5/4 log 3. Again, I've got x's in 2 terms. Take it out as a GCF. Okay? Then divide by that entire thing that x is being multiplied by. So x equals 5/4 log 3 divided by log 7 minus log 3, which is 1.6208. for time's sake. That way I can still give you this natural log example. The only difference between this problem and this problem is that you needed to multiply that exponent by 1/4. Everything else, you're pretty much the same steps. Okay? When you have x's on both sides, you move them to one side, factor it out as a GCF. Alright? It's just a lot of writing and a lot of steps. This next example, 4e to the negative 0.3x minus 7 equals 13. I want e to the negative 0.3x by itself. So I'm going to add my 7. That gives me 20. Then divide by 4. That gives me 5. Okay, I have e as my base. So I'm not going to take the log of e. I'm going to take the natural log of both sides. Move my exponent to the front. Okay, well, what's the natural log of e? Natural log of e is 1. So I just have negative 0.3x equals natural log of 5. So I just divide by negative 0.3. Which is a negative 5.3648. Okay. I want you to recognize that on this next example, when you subtract your 2, you get a negative 7, right? Alright, if I go and take the log of negative 7, what happens? You can't do that. No solution. Now, obviously on your worksheet, I want you showing more work than this, but because you'll have like 3 minutes to the bell, I'm just showing you the right side. Okay? So make sure you recognize when you go to take the log of both sides, if you take the log of a negative, then it's no solution. Okay? Y'all will have a quiz over this.